and start. Welcome. This is the Open Research Institute FPGA Meetup, and it is the 24th of February, 2026. And what we do at this meeting is talk about what we have done, what we have planned to do, if we need any resources that ORI can provide or help you get, and to talk about the roadblocks, the challenges that we're facing, the things that are in our way. First up on our agenda is OpenCPI updates from Aaron. If you have any, please, you're welcome to take the floor.
Sure. Thank you, Michelle. So this last week, I've been continuing to work on the on packet injector. We'll take IP data and then shove it into the encoder. I moved the implementation that I was working with into a separate thread so that I can do OpenCPI things, and then started the big, it's not that big, but the fragmentation. So IP packets are bigger than baseband frames, so we have to break them up into smaller chunks properly. So I've been working on that. I've been using Claude for that, which has been very helpful. But I'm still not at a point where it's a complete end-to-end solution yet, but it's still work in progress. And then on another note, last week we'd mentioned the ZC102. I was able to build the but the padding GSC implementation that I currently have working on the 102 and successfully get it to transmit on that device, as well as the 106. So part of OpenCPI allows you to leverage cheaper hardware to develop on, and then when it's time to deploy on larger hardware, you can just build for it and execute it. So I just wanted to test that out and get that going, and make sure everything was still working as intended, and it does. And then there was one more thing, but for next week, I do plan on continuing the work to get the end-to-end actual IP data. So that's what I have going on.
Wow, thank you. Yeah, it sounds like a pretty good case study proving out the value of OpenCPI. As we all know, porting from one platform to another can be challenging and difficult, and it's a lot of time that would be saved by a framework like OpenCPI. So it's great news, and I look forward to duplicating it in our lab. We have the ZC102, and I'd like to try to get that up and running, just to show it off. So looking
Yeah.
forward to that. Okay, next up on the on our list is Opulent Voice Protocol and implementation updates. Any hardware and software modem work. So I'll turn it over to Paul in case you have anything to add or anything going on.
Yeah, I have a brief report. Um, Having all of which have to do with the power estimator that Matthew added to the HDL, and that was a while ago, months ago. It was added, and I haven't been able to get it to work. And we've found out why since the last meeting. Turns out there are a couple of configuration registers that have to be set to something other than 0 to actually make that filter work. They're named low pass EMA alpha 1 and low pass EMA alpha 2. And for some reason, those names just didn't click to me with having to do with the power estimator. So they were left at 0. And sure enough, that meant the power estimation was always 0. Working as designed. Maybe a few more words in a documentation would have been helpful. So we got that working, thanks to Matthew for pointing out what the issue actually was. And then it became time to validate the power estimator and try to get some idea of how well it worked and how it corresponded to reality. And it turns out we have 2 power estimation capabilities in the hardware. This one that Matthew created in the HDL is digital and tells you what it's seeing in the digital world after sampling. But there's also an estimator in the radio chip, which they call RSSI. That's industry standard term meaning received signal strength indication. And it's a relative value, but it's a useful calibration point for us. And we've been using that in lieu of the power estimator uh, from the beginning because it worked and we knew how to make it work. So we ran a little test um, just to see what we could learn about these two power estimators. And let me start with some pictures here. So let me share my screen. I will start with this one. You should see a picture of my hand holding a couple of inline attenuators. These are going to be our reference standard. These are mini circuits attenuators. They come in values of 3 dB, 6 dB, and multiples of 10 dB. So 10, 20, and 30 is what I have here in stock. And by putting them end to end and putting them in the circuit between a transmitter and the receiver, you can reduce the power coming out of the transmitter in a way that's relatively traceable. These are really pretty close to the number of decibels they claim of attenuation. So now I've got three things that can measure power. There's these attenuators that are calibrated sort of, and I have checked them against the spectrum analyzer, and they seem to be pretty close to what they claim to be. And the RSSI indication from the radio and the power register. So I put every possible combination of these inline attenuators between LibreSDR configured to transmit the waveform and another LibreSDR configured to just receive, and through a cable, of course, and added these inline attenuators to get different values. And the raw data then looks like this. Yeah, you should be able to see a nice nice table of numbers. If you look at my personal screen, you'll see me holding up a notebook. That's what it originally looked like as I scribbled it all down. But the what you see on the screen share is the same information transcribed. You can see the first column is how many dB of extra attenuation I stuck in, and then the second column is what the RSSI indicator said, and the third column is what the power indicator said. I also put in the standard deviation of those so you could see how much the spread was and how many points I measured. I just ran it for about a minute at each setting by hand, so it wasn't exactly the same number of points each time, but substantially the same. And you can see that over a range of 0 extra attenuation to about 30 dB of extra attenuation, it was locked, or in the last data point there, it's only mostly locked. So it was dropping out of lock occasionally. And then below that, it was just plain unlocked. It couldn't see the power at all. And so the first thing I want to do is see if that RSSI value was right. So I have got to figure out the right thing to click. Here we go. This graph shows what the RSSI looks like against these inline attenuators. And that's a pretty good straight line for quick lab work. And in the legend box, you can see there's the straight line equation has a gain value between the attenuators and the RSSI readings of about 0.945. Ideally, that would be 1.0, but that's pretty close. You can see the difference as you look at the actual values. Doesn't read directly in dB, but it reads in slightly less than a dB. So that's useful and good. And then the next question is, what does the average power indication look like? And I will graph that for you as well, magically. This is what it all looks like. This is the entire data set. There's a little tiny red point for each data point that I took, and they're all blurred together because I took so many data points. But you can see up from 0 extra attenuation all the way to 26 or so dB of extra attenuation. The number that you get out of the power indicator is nearly constant. It's bopping around near 1100. And that's because the radio has AGC, automatic gain control. So it's adjusting the value going into the analog to digital converter to be at some nominal value. And that value translates to about 1100 on the power estimator. And then once you get past the point where the AGC is kicking in, it drops off more or less linearly we get two data points here that are pretty high, like around 500 and 400. Those have to be 29 and 30 because I can make a 9 out of 3 and 6, and then I can go up to 30. So I get two close points, and they're in the middle of the range near 500, pretty solidly. They don't have a lot of distribution. And then one more point around 150 that's very detectable, even though that's beyond where, right where the modem is already falling out of lock. So if I use this signal strength power estimator to detect a signal before even trying to acquire it, I could do a pretty good job of deciding whether it was acquirable or not. If I set a threshold, maybe 400 or 300, something like that, any value above that, I'm going to be able to demodulate. And any value below that is going to be either dicey or invisible. And the last couple of data points here are reading exactly 0. So if I don't find any signal, or if I find a signal that may be detectable on a spectrum analyzer or a narrowband receiver, but not demodulatable by this demodulator, then I'm going to get 0 out of the power detector. And I know that I might as well skip over those data points. So what we found here is nothing surprising. It worked. The power estimator gives a value that is usable and reflects what we want to know, and it matches with the DB, with the RSSI, which matches with the actual attenuators pretty closely. So that's the end of that experiment, and we call it a success. I see a hand up from Oscar. So.
Okay, I do have a question because you did a little bit more experiment. One more, you need to calibrate what will be either your threshold or your maximum power. If sort of you can get like a signal generator or something like that, or so you know how many minus dBs that you can receive. Like typically it's about 0.15 micro volts, or even in the new radios, you can go a little bit lower, like in cell phones. Those translate in dBs minus 126, minus 126 to minus 150, the excellent radios, to be calibrated just for reference.
Okay. Yeah.
So you need a standard signal just to calibrate.
If we were trying to make an actual measurement, that would be super important.
Yeah, because you want to know the sensitivity of your receiver, the real sensitivity. Well, your experiment is perfect. That sounds great, but you need to just to calibrate what is your limit of sensitivity.
Yes, you're right. And take a look at this picture. The spectrum analyzer is what the signal looks like at threshold, where it's just starting to fall out of lock. You can see, notice, look at the numbers on the left-hand side. That's around minus 88 at the peak. So that gives you some idea. Now, remember, we're talking about a lab device here that doesn't have a preamp on it. It doesn't have anything in the way of bandpass filtering. This is just on the desktop. So we can do better with this radio. But we can receive it down to where the sidebands are pretty much buried in the noise. And we've only got, what is it, like 105 to 85, maybe 20 dB of peak to noise level ratio. So that's as close as I've got to actual calibration yet. Actual calibration of LibreSDR by itself is probably not that useful, because we probably want to put a preamp at the antenna to get a real estimate. So I'm going to leave it here for now. And if we need some actual more numbers, I'm more interested in measuring other things relatively, frankly. I'd like to repeat this measurement with the frequency error, for instance, and see how sensitive to frequency the two measurements are. Because when we're first acquiring a signal, we won't have a perfect frequency match like we do in this experiment. Almost perfect, because both had been calibrated just the previous day at room temperature, and of course the experiment was run at room temperature. And
yeah, an easy way to simulate a frequency offset is just to set the transmit or receive NCOs off. You could compute the amount for a ppm variant, but in that way you don't have to keep messing with oscillators. You can determine a frequency offset just by changing the NCOs programming.
That's right. I can also change the calibration value in the LibreSDR firmware, which offsets frequency and also all the other clocks at the same time, which would, I mean, that won't matter, but it's a more accurate simulation of Doppler.
Yeah.
Okay. And that's been all the work I've done on this project for the last week. So, end of my report. End of my screen sharing.
Thank you. And I think we can also compare this work on the LibreSDR, which is the hardware modem, Locutus. And we saw that there might be a different behavior, slightly different behavior with the software modem on a Pluto when we were connecting them in the lab. And so now that we have a better handle on how to measure this, that we might be able to get some similar results for the software modem.
Yeah, that's a good idea. We should run that test.
Cool. Looking forward to that. We should be able to do that over the next week. And yeah, the point from Oscar is well taken. I think it'd be super useful to get minimum discernible signal, something like that. And then, some calibrated numbers. I think that'll be really exciting. Because so far we're seeing what we expect, given the modulation and the theory behind all of this. So it's always gratifying to have that happen. So thank you.
And while we're doing that, the other thing that I didn't do in this test is to actually listen to the signal and see what the vocoder does as the signal goes down. This has been a notorious problem with other vocoders. Some of the lower bitrate vocoders tend to turn into R2D2 when the signal gets bad, and they turn into bleeps and blorps and annoying noises. Opus should be better at that, but we should prove it.
Very good. It sounds like we have a lot of action items.
Yeah, always.
Yeah. Yeah. Thank you, Paul. Okay, next on the list is AMSAT-UK. This is AMSAT United Kingdom. The Mode Dynamic Transponder is part of the FunCube Plus satellite. And what we're providing to AMSAT-UK is technical support on the Mode Dynamic Transponder and our successive interference cancellation design. This is a VHDL open source design that uses SIC, or successive interference cancellation, in order to achieve weak signal work on 70 centimeters from orbit. So the Python model, very promising, and initial VHDL model work began. And as of last week, the tests are passing. So we had some test benches for each of the individual parts of the VHDL design. So after that, we went back and reported our work to AMSAT-UK and to try to see, like, okay, how are things going over there? Because they've had a number of meetings for the FunCube Plus satellite as a whole. So we're part of it. It looks like we may need to take on more of the design. So our strength and what we can do, probably the quickest and the best, is the FPGA work. The FPGA and processor pairing in the FunCube Plus for the MDT is slightly different than what we usually do. We usually have a relatively large FPGA, and we use the general purpose processor for the things that the FPGA cannot do. For the FunCube Plus, the FPGA is small. It's an ICE40, and the STM is the processor. There's a fairly beefy STM processor that's paired with it. So most of the work will probably be done in the microprocessor. So in order to get this on the spacecraft, I think that we're going to have to take on more of the design and to go ahead and prototype more of it. So we were talking this over at the board level, so ORI board of directors, and yeah, I think the consensus is we'll see what we can do. So the first priority is to get the VHDL working. So it is passing its test benches. And next is to go ahead and press forward on that and to see if we can start actually using it, in one of the dev boards that we have. And then we may need to write some general purpose code in order to handle the processing of the signals that are then identified, pulled out of the bandwidth that we're looking at, sent off for processing. And so over the next week, we'll explore that and see what happens, and continue to talk with AMSAT-UK just to make sure that they know that they're supported, and that at the very least we'll have the FPGA work provided to them. The launch is this year, so it's coming up, and we are expecting to have a 1U, like an actual flight board layout and build done. So I'm keeping a close eye on that to see if we may need to help make that happen a little faster or not. So all of this is for a scheduled launch, the FunCube Plus from AMSAT-UK. So please go to their website and check it out. It's a really interesting project. This is a follow-on to the extremely successful FunCube satellite launch. So now a couple of decades ago, which if you're familiar with the FunCube dongle, that's where that comes from. So it's a really, thank you very much to AMSAT-UK for the collaboration and the cooperation. That's been a joy to work with all the people and to meet them. And we look forward to finishing the design, and regardless of whether it ends up being included on the FunCube Plus, it'll be available for anybody to use. And hopefully a way to learn about polyphase filter banks, because that's how we're doing the successive interference cancellation. We're trying to document this as fully as possible and to have a working Python model as well as the VHDL. All right, so that's the MDT report. Next up is we will be at RF Village at B-Sides, San Diego on the 4th of April. This is at San Diego State University. It's a single-day event, and we have a pretty good crew for our RF Village, or Radio Frequency Village. We have a self-contained CTF, or Capture the Flag, and this is satellite themed. It is a challenge based on an actual lunar lander, the Vikram from the Indian Space Research Organization, or ISRO. And this successful lander that landed on the moon used a radar altimeter to figure out how far away it was from the surface of the moon and how fast it was approaching the moon. And when we read the article in IEEE, one of the IEEE magazines, the VHDL code was not shared, so it's not an open source design. However, the paper went into great detail and about the state machines and the different functions that you can use to then duplicate their design. Now, since we're interested in radar and VHDL and FPGA and also Verilog, we took a stab at doing this up in Python. And guess what? There was a big bug in there. And we took the opportunity to turn this Python model into a Capture the Flag contest. So it's a really good educational opportunity. It has to do with state machines. It has to do with radar altimeters. It has to do with spacecraft landed on the moon. So this CTF will be premiered at B-Sides on the 4th of April. So if you happen to be on our Slack, you may notice that there's an opportunity to review the code and to test it out, take a crack at it, be kind of quiet about it. Don't spread it around too publicly, but please go ahead and check it out if you're on Slack, and let us know if there's any way to improve it. So this is a sort of an educational outreach, and also, spacecraft and sort of satellite radar altimeter project. So thanks to everybody that has helped to make this happen. It's been super fun to do. Other things at RF Village at B-Sides, we're going to bring the RF bit banger. So we have a volunteer that will handle distributing and taking donations for the RF bit banger HF QRP kit. There's a lot of interest in Mesh-tastic and Mesh Core. So there's multiple people from the area, from San Diego, that are going to bring demos and stations for Mesh-tastic or Mesh Core. And we also have Opulent Voice. We're going to demonstrate Opulent Voice live and explain it and show it off to folks. And there will undoubtedly be more at the village. So if you're in the San Diego area, please consider coming to B-Sides. Tickets are on sale. We have that listed and cross-listed through IEEE. Next on the list, we've talked about the ESA FutureGEO presentations. This is a GEO or HEO satellite for amateur radio. This is a initiative led by the European Space Agency. It's funded. The big primary investigator or the main sort of contractor is AMSAT-DL or AMSAT Germany. So we're coordinating through them. And the next big workshop for FutureGEO will be at Friedrichshafen in June 2026. So coming right up, this is where proposals will be presented. And so we are going to be there to present and to demonstrate. So AMSAT-DL has offered us booth space, and I went ahead and accepted the offer and making sure that they have power at the booth. And I've asked exactly how much space we have so that we know exactly how much to bring and that we can set it up and try it out and do some videos ahead of time. So big opportunity for high Freya, because Opulent Voice only works really in space with high Freya and the rest of the system. So if we're going to try to bring anything and everything that we can carry onto a plane and go there and enjoy. So Friedrichshafen, very large amateur radio event, and it has a very strong software-defined radio and digital modes component to it. So this is a really good place to meet. Okay, that's all I've got on my list. So the floor is open for any other updates, any work that anybody has done over the past week, anything they have planned over the next week, or any roadblocks or resources needed, any of those sorts of things. Floor is open.
I can give a bit of an update.
Yes, please, go ahead.
I didn't do a lot of technical work this week, but one of the things I did do is I created a document. I pushed it into the Pluto MSK top. That's just a list of tools that are needed for working with the modem repository and modem code. And then also maybe like some suggested tools. I recently started looking at VS Code for an IDE and type environment. And they actually have some really nice RTL plugins, and they even have a waveform viewer that's an extension. So you could just click on the waveform file in the editor and load up the signals you want, which is kind of neat. It works pretty well. So anyways, I've added that. There's some more updates I need to do for the extensions, documenting those, because I think beyond that, I'm hoping to get back into working on the other lock detector mechanism for the next week.
Excellent. Okay, and thank you very much for the very fine article that you wrote about the symbol lock mechanisms and code. So that's placed in the March newsletter, and just give me if you have an update to the PDF that you shared, then I can very easily update it in the newsletter. Newsletter will go out more towards the end of March, so plenty of time. But it looks fantastic and very appreciated.
Yeah, I will. I might I know rearrange it a little bit, or for the newsletter version, but at least it's mostly there, and I'd like to put in some details on the alternate lock circuit as well. So there will be some updates, but most of the content is there, and hopefully the math is good.
Excellent. Yeah, thank you so much. Right. Hey, Oscar, you got anything to share from okay. Well, thank you so much, Oscar. Oscar is at the University of Puerto Rico and leads a fantastic, or enables and supports a fantastic student team. And it's really wonderful to work with them and to let us know if we can help in any way, over the spring. All right, and welcome to HG. And if you'd like to introduce yourself and let us know your interest in open source digital radio, then please, you have the floor. Okay, nothing heard yet, but interrupt us at any point if you'd like to share. And then uh, Rick or Adrian, if you have any stories or updates or anything you'd like to share, the floor is yours.
Artemis 2 is doing what we expected from NASA. So we have more time again. It's going into April now to refine our design and software, and we are doing just that. We're putting in more effort on defining the characteristics of our 60-foot dish. I'm working on getting the rubidium HP 5065 back from the West Coast, where it has been updated to the super rubidium version with additional optical filters that Hewlett-Packard never dreamed possible, which adds almost 10 dB of lower noise performance on its Allen deviation charts. In the meantime, mine is at Haswell doing just fine. I'm looking at a chart that I did yesterday showing that over the past week or so, averaging plus 7.4 times 10 to the minus 13 frequency accuracy as compared with GPS. And that's significantly better than the specification for such devices, but it has to do with tender loving care and careful calibration. And so we're feeding that 10 megahertz into two different systems that we're going to use in parallel for monitoring the manned spaceflight mission when it does go up. And so everything is coming along nicely. We have a brand new design for mounting feeds in our dish, which we now have time to implement, which gives us infinite adjustability in X, Y, and Z for positioning our various feeds. We have feeds from 400 megahertz up through 8.5 gigahertz, and we're trying to get them all calibrated and working for their various different missions. So a lot of work has been going on, and the Artemis mission has actually been a good catalyst for getting everything at Haswell running better.
There's nothing quite like a deadline.
Yes. And in the meantime, I'm learning a great deal about remote operating because first, on the way back from Haswell a couple of weeks ago, my engine demolished itself. So my truck has just got returned yesterday with a brand spanking new, not rebuilt factory engine. So I'm waiting to see how long it'll take for that one to blow up because they have a known failure mechanism in that engine, which will reoccur on the new engine. But anyway, just after that happened, I had my right foot operated on, so I can't drive anyway. So I'm refining my understanding of tail scale, rust desk, and various competitors to rust desk, and all things remote access. So I can sit here comfortably with a painful foot in a great big 5-pound boot that I'm not supposed to walk on.
Nothing quite like constraints to
And
force
it
your
also
hand
gives
on
me,
creativity.
it also gave me time to try something. I've got this Python program that I started writing about 6 years ago, just before I moved to Colorado, to replace MATLAB because I was tired of paying the fees. And Python, everything I needed, Python could do as well or better than MATLAB. So I said, okay. And I didn't know what I was doing. I'm a pretty good programmer in other languages, but I didn't know what I was doing. So 5 years later, I have this, 10,000 lines of Python, and I can't find the line that's in the section that does what I want to change. So I said, well, how am I going to fix this spaghetti code? And I'd already moved my IDE from Spider to Visual Studio Code. And that's part of my coming up into the 21st century with the tools that other people are using. And I had plugged into it a paid for version of Claude code. And I said, well, I don't know if I'm ever going to use AI, but I just plugged it in because I was learning how to do it. So I typed up a paragraph that I had no idea that there was actually a single word to describe what I was trying to tell Claude I wanted it to do. But I wrote up this paragraph and sent it to Claude Code and said, my code is a mess. Can you help me restructure it and put it in different files and arrange it so it makes sense? If I knew what I was doing, I would have said, Claude, could you just refactor my code? But I didn't know the name refactor. That was last week, see. Well, Claude took my code and it has completely restructured it, put all the features that are in there in different files, put all the constants in another file, just structured everything for me. And I pushed go and the sucker ran just fine, just as it did before. And now I can find the section that I want to change because it's in a file all by itself with a name that makes sense. I didn't invent the name, Claude did. And I said, well, the next time I say I'm not doing AI, I kick myself because that thing works. But that's my learning experience for the week.
Yeah, no, that's a good one.
I see lots of yes and up. Oscar's obviously been through this long before I did. I just discovered last week that I could do something useful without straining too many brain cells. Just ask Claude to do it for me.
You already strained your brain cells by producing the code in the first place. And sometimes when we're not, black belts at, say, Python, or in my case, C++, you can describe or you can code it, and it might be kind of messy and old-fashioned or naive code. And a good LLM will dramatically help you. This is really a big strength of the large language models, is to help you organize things or to refactor. That's a big strength. And I think it's the right tool for the job.
Well, as an electrical engineer with 3 degrees, I'm not a programmer. But I've tried over the years to be the best programmer I can be, but I'm still want to design electronics. So this is a very big help because I can write things and they can actually work, and then I can ask the AI thing, would you straighten it out for me? It's essentially teaching me how I should have done it in the first place, making me a better programmer.
Yeah, it's the right tool for the job. It's a really good example.
A lot of fun.
It is.
Oh, your background is wrong. Okay, this is the month and into next month where Colorado gets most of its snow for the whole year.
Yeah. Same with
It
Palomar
is
Mountain, where this
63, it
yeah.
is 63 degrees. The sun is shining, the sky is blue. It's July in Colorado. What the hell? Over.
Understand. Yeah, behind me, this is Palomar Mountain and about a, you know, maybe 90-minute drive from here. And this
You
was
guys,
this was photographed in March a number of years ago. March
Oh.
is when we get the most amount of snow. So we're coming up on the season where we usually get the really heavy sudden snowfalls. So
well,
that's
you
why
guys actually got some snow, as did Western Colorado. But out here, it's like summertime.
yeah, interesting, isn't it?
Well, I'm not sure it's good because that means it's going to be a tough fire season.
Yeah, same here. Might be. Well, Rick, I think for anybody that doesn't know, when you say Haswell and you say we, maybe you should just say a couple of sentences about Deep Space Exploration
Oh,
Society.
of course. When I moved to Colorado, I discovered this wonderful group of people who very quietly obtained ownership of a 60-foot radio telescope that was originally designed for terrestrial work. But they've turned it into a radio astronomy site called Deep Space Exploration Society. They have a website that I'm happy to contribute to called dses.science. I didn't know there was a .science, but there is. And that little group, since I moved here, has expanded and is now, I think, about 4 times the size it was when I first met these gentlemen. And we are now involved in many projects of ham radio and space science, and now cooperation with NASA on the upcoming manned space mission. And we're even building a payload to try to duplicate what others have done in Europe and receive signals from faraway satellites that are outside of the solar system.
Cool. Yeah, I'm looking forward to that
So
happening. That's
we're doing a myriad of projects. If you look at the DSES.science website, at the top are some selections. If you choose membership, you can join. I like that. If you choose projects, you'll see a dozen or so projects that we're doing that are a lot of fun, some of which you can contribute to remotely. And if you look under science, you'll see the success we've been having lately on pulsars and magnetar detection and such things as that.
Yeah, Deep Space Exploration Society is one of a number of really amazing amateur astronomy and amateur radio sites around the world. So 60-foot dish is no joke, and it's a significant, significant resource out there in education and experimentation. The others that we work with are Dwingelo in the Netherlands, and also Stockert in Germany, and a couple of others around the world. So these are really neat resources. So when you see them, it takes a lot of work especially to rehabilitate an old radar dish. That's a tremendous amount of work. Not these sites don't come along very often, so they're resources. They're usually supported by a nonprofit or other sort of organization, and a lot of them are fortunate to have sponsorship from industry and also from academia. So
yeah, we are a
lots of neat stuff out there.
501c3, and even membership dues are tax deductible because we don't give away sweatshirts with our membership.
Yeah, the .science top level domain is a neat one. And like for instance, Open Research .institute. We have a .institute top level domain, which is good to have.
Oscar,
Really kind of sets you apart from the .coms and .orgs and .nets and all. Oh, go ahead.
Oscar had a question.
Hey, Rick, I'm sorry to interrupt your conversation. Quite interesting. I just wanted to let you know, working as a researcher at the University of Puerto Rico for 45 years, we are moving forward to high-end electronics, embracing the AI, embracing the machine learning, and then the AI. For example, this little geezer here,
Yeah.
26 TOPS, tera operations per second. And you can put it in a Raspberry Pi or modules like that and run it. It's a Halo. The new one on the market is 40 TOPS, tera operations per second. And if I change here my camera and look in the screen, you will see that the advances of AI that we are doing with the CPUs, the common algorithm of machine learning, clustering, random forest, k-means, Gaussian regression. And now with the Halo, we are going to look into the anomalies for looking specific and teaching the device to do check for the anomalies for the isolation forest, C-score, and local outlier factors. And as you said, we use Claude. The students use Claude. They learn how to program. They do program in Python, but at the same time, we don't have the time. We are competing. We have to meet deadlines. We have to use the tools that allow us to do programming. And if I show my student right now, he's working over there in the software, in the flying software with the AI. You can see wire sensors, and they are fully operational, measuring magnetic fields of 1 nanotesla from space into the aurora borealis. We have wonderful data that we get, and we are teaching how to look for these anomalies. Wrong camera. From these anomalies, and you see the oscillation, how it dropped that for looking for the ambipolar potential that is taking our gas at the cost to space. So we have a limited lifetime on Earth because we're losing the gas. And it's because it's about 1.1 volts that is taking supersonic speed all the ions. Once they are ionized, they go to space and we lose them. So we're losing water. And, and our students are beautiful looking into the magnetic fields like this one. And this is done by AI already. We want to do that during the flight. And I'm looking forward for one of the data, if I can find it shortly. Real data collected. Where do I have that? Let me open the right file. Preliminary data, this one. Let her open. Actually, I sent this one today to Honeywell, to a colleague, and I just want to show you these two signals. Look at this beauty. And this is the base before launch of one of our magnetic sensor XYZ. And you can see that it's plus minus 2.5 nanoteslas. That's the noise level. And you can see the blue, that is launch. The red is X, the blue is Y, and the B is Z. And you can see how they change. And this is the data, how we did measure inside the Aurora Borealis at the cusp from Nandoya, Norway. This flight was November 18, 2025, a few months ago. Now, I can show you in 2D graph, and this is when it goes up to the top, up to about 260 kilometers. So we measure the magnetic field. That is very difficult to measure the electric field because the ions, they get reunited, but the currents are there, which the atmosphere do not affect. So we're going to a different approach from what NASA had done by measuring the magnetic field. So this is the anomaly. But next one, wait until we finish. And again, we are using, as you said, the cloud. This is in 3D, X, Y, Z versus time. Look how beautiful. That's before launch, that's launch. And now this is in slow spin, about 14 seconds in space. And you see how beautiful in X, Y, Z, how it comes out. It looks like a simulation. It is, and this is real data, raw, not massage.
Outstanding.
That is amazing. Oh, look at this.
Yes, and we are looking for colleagues to understand these things and come back and to teach the student how to work in teams, because this is the important part, not to work alone. You have to share and share with everybody how to improve your data. And
That's right.
and they're doing amazing things. And again, I told you, computer power, 26 trillion operations per second in
That's
this
amazing.
board. And this costs less than $50, okay?
Yeah, it's a golden age, really.
Yeah. But I hear you talking about, and you're doing the programming, but you are doing the right thing. You have to move forward. Everybody else in the world is pulling out these things. Even the programming of the new CPU and the science is done by AI itself and analyzed, because we don't have the time by hand. It's too many, it's too many chips, too much memory, too many algorithms inside a CPU with the MPUs, exactly, graphic MPUs and memory and buffers.
Yeah.
It goes out of our hand.
Yeah, you have to divide the problem. You have to divide it. You have to say, here's the complexity that can be automated. And
Yes.
then that is no longer a drag on your schedule. The stuff that's very difficult to automate, that requires people to figure out and to manage, then you have people figure it
For
out.
example, Rick, I'm sorry, Michelle, you just mentioned that you want to build a payload to do measurements on space. Yes, you have to build a payload and you have to learn to put into the AI to do the analysis on space, because you may not have contact with the payload because it's on the other side of the moon or the side of the planet, and you have to be doing the analysis. And then when you have the right time to send the data by laser or whatever means, then you send the data. But at the same time, the payload have to do the work that you cannot be 24/7 sitting in front of a monitor.
That's right.
Yes. Yes. The only caution I have experienced is if you are not really, really careful in how you present the problem to AI, you might get the wrong answer.
Yes.
So testing and automated testing is becoming more important than it ever has in my career.
Yeah.
Agree, but these are baby steps. We are in the baby step. We are teaching the AI how to do it. And in 2 years, it's going to be better. And then it will learn more, and you will have to create this database information and teach it more and more and more. And what will happen in 10 years? We will not be here, but it's going to be taught, and it's going to learn, and it's going to be doing half of the science.
Yeah.
And
Well,
are you going to
I
Pluto
will
to
be
do?
here in
Are
10
you going to
years.
Jupiter 16 years to do the experiment over there that it takes just to get into the Europa moon? No, we won't be here.
Or even
The
longer.
students have to do it, but again, it takes 20 minutes to get the signal here. So let it do it. I mean, teach it. We have to teach these units so they can work 24/7, and they don't need water, food, gravity.
Yeah,
We have to do the analysis.
You got your work cut out for you, Oscar, with all the
No,
teaching.
but yeah. But,
no, as a teacher, you have your work cut out for you. You have to present
Michelle,
and enable the students to do it the right way.
I started in
encourage
1977 doing experiment, 45 years of service in research, and they pour the money out. They put the money for you to do the signal measurement, things like that, because they know that you can do it. But at the same time, we're slingshot the student to the front end to do the same AI, to do DNA analysis, amino acid, and different polymers. And one of my students just wrote the process to do DNA analysis in the moon and Mars.
Right on.
And she's going back this summer to work with Kennedy. And they know more than I know. But I know how to think a little bit and organize them, and I slingshot them into the future.
Yes. Not every educator has that approach. So I like your approach. I think it's the right way to do it.
And, they get scholarship to do the PhDs. Full scholarship. They go into the different universities.
Good.
That's a wonderful thing that you're doing.
And it's not me. Forget about me. Take me out of the equation. Let's embrace the technology. Let's embrace the advances. Let's embrace what we can do.
Well, I say what I say in all earnestness because I think I'm a reasonably good engineer, but I tried teaching. I can't do it. I don't have the skill to teach other people. Sometimes one-on-one, but what you're doing, I have a great deal of respect for those who can teach.
And I go back home and I'm doing this power analysis, signal sensitivity, so on, because this is what ham radio, because we're all here because we're tied up with ham radio. And one of the biggest problems that I have is what small signal I can listen. That's your expertise. I agree with you. And you better know what is the limits, what are the calibration, and which radio, which front end, what is the limit. We will have soon, and I will talk with Michelle as well. This guy from Sherwood, he's going to come and give us a presentation for the quality of the radios and the low signal, low noise of the radios, not only the sensitivity. So this is another way of seeing the same thing, but what's the quality of the signal as well.
You're talking Sherwood, who lives down the road from me.
Probably this, probably
lives,
the one that have the Sherwood page and talk about the sensitivity of the radios.
Yeah,
he
that
lives about as far north of Denver as I am south of Denver.
Yeah, I'm in Puerto Rico, okay, in the Caribbean with all the hurricanes.
Puerto Rico's a little further away.
Very good.
And anyway, sorry
great.
to bother you.
When is the Sherwood folks?
I will double check and I will send you the schedule for sure.
Oh, okay.
And Michelle, I think that you should give a presentation of these things that you're doing for the how you call it, the European equivalent of AMSAT. I think you should give a presentation on this story and what you're doing. Yeah. Please.
They've both AMSAT-DL and AMSAT-UK have been very good to us, and we've presented at their symposiums over the past year. So they've heard it. But yeah, we should give a presentation to summarize it and probably put it on our YouTube.
Yeah, because and it can be done by YouTube. It can be done on Rackpack, I know, but it can be done. I would ask for that.
Okay. Yeah, sure. And also, coming up, Friedrichshafen is another opportunity to present to people. We had a presentation at FOSDEM, so we are getting the word out as best we can.
Yes, and I think this is a community that listen to it. And anyway, it's not the question to listen. We have to transfer our knowledge.
Yep, that's right.
This is part of our responsibility.
Yes. Yeah, we take that very seriously, and we try to do the best we can.
Sorry for the interruption.
Oh, no worries. There's an artificial intelligence machine learning article that we did. It will be in QEX in the next issue, I think it's either May, June, or let's see, January, February, March, so maybe April, May. So if you are a QEX subscriber, then our artificially intelligent RTTY, that's right, radio teletype receiver, where we walk you through the entire process of building a machine learning model to do receiving. So what does it mean to have an AI receiver? And then we compare the performance to, what you would get with, say, any other receiver for RTTY. So the results were really good. And it just opens up the whole process. So it sort of walks you through how you make a machine learning model that does receiving, how you train it, and all that, and how you can duplicate the results. So that'll be coming up in next, a very soon issue, if not the current issue of QEX, but coming up in the spring.
Send me the link if possible. Go ahead, Rick.
Will do.
The thing that kicked me off on this Python kick in the first place was this book.
Yeah. I have it in PDF and we read it all the time.
Yeah, I started reading this book and it said, "Oh, you really need to know Python."
Yeah.
And it got me completely off in a different direction. But I'm getting back to the machine learning thing here.
Anyway, I apologize for taking the time.
Oh, no, that's what we're here for. This is office hours and open discussion, and
And
I'm
definitely, I
excited
want to.
about the things you're doing there. This is fantastic.
Send me the link of when do you expect to be, even if I have to register or whatever, I will do it. I can
Yeah,
get
I'll
a couple.
send as soon as as soon as the issue is published, then I'll get then we'll be able to share the PDF with permission. So I just ask permission and send out the PDF. So if you wanted to distribute it to your students, no problem. But it'll be in a nice PDF format when they're done with all the layout and redoing my graphics, so that's coming right up. I'm excited about it because we submitted this article a year ago. And with a lot, as you know, with a lot of magazines and journals, it can take a while for the reviewers to look at it and then make it, and then the editor and then the scheduling. So it ends up taking a little over a year, um, which, over the past couple of years because I'm a reviewer for QEX magazine. So if anybody's out there, if you're a member of ARRL and you would like to volunteer to help be a technical reviewer for QEX, like if you've ever looked at QEX and you want to know why there isn't any more digital or more whatever type of article, and if you have a competence here, then ARL could certainly use you. It's been a very good experience to do that. But as a reviewer, I know how long the process can take. As a volunteer for IEEE, same story there too. Uh,
Let me tell something to Rick.
Sure.
Rick, for time base, check on the articles. You can go anywhere in the internet. Time crystals. They are being used for computer or entanglement, and they are oscillating the crystal by itself. Time crystal. This is just came out in the last 2 years, and those are the keywords.
Like
Okay.
IEEE, like check IEEE, Oscar, or
Well, they're coming. They're coming in ABC, NBC, so on. Those scientific articles, and then you go into the real papers, following back the reference, and these are very stable, and the keywords are time crystals.
I see lots of results by just putting that word in here. So I'll
And those are stable,
investigate.
and you're looking for application like stability much better
Oh,
than GPS and things like that.
I don't like this subtitle, 4D matter. Oh, this sounds like it's going to be an interesting
well,
deep dive.
Oscar
He's
did.
going to be busy for a little while.
That's right.
Uh,
Oscar, you did mention entanglement, right?
Yes.
All right, quantum all the way, Rick.
oh, I do. Well, that's my hobby is studying quantum mechanics
He's going to be busy
because
reading.
Oh yeah, you'll
uh,
like this, Ed. Yeah, we routinely give Rick assignments here. He's
Oh,
good.
this is for enjoyment.
Oh yeah, no.
He can put it in, he can apply it, but
Mhm. Very good. Time crystals, I love it.
okay.
All right, anybody else? Any questions, comments, projects, resources they need or roadblocks? Let's see, Paul found the FunCube 1 launch date, November 21st, 2013. So that was the previous, I believe that was the most recent previous FunCube 1, right?
I was looking for the first one. You said decades, and it was only like a decade and a bit.
Oh, okay. Yeah, I thought there was one that was before 2000, but I happy to quote you on the FunCube 1 launch date. I think that was the one that had the dongle, the FunCube 1 dongle, because it's
Okay.
essentially a RTL SDR, but tuned up and aimed towards amateur radio and amateur radio satellite users, and a good reputation. And I think it's still out there as far as I know. But yeah, we're looking forward to a launch for the FunCube Plus later this year, and yeah, just as I learn more and as we manage to get more working, we'll talk about it here. Um, and yeah, it's just been a really good experience to collaborate with AMSAT UK.
I think this is really good.
Yeah, I'm hoping
We
that
have to
that
pump our
AMSAT
guys. We need to.
Yeah. No, we gotta work with the
I said it
work
all
with the
by not
good
saying
people.
anything.
Yeah, yeah. No, it's good. I'm very happy about the way things have evolved. This collaboration came about because the AMSAT UK people were at the AMSAT-DL or AMSAT Germany symposium back in September. And that was also a site of one of the FutureGEO workshops. So the ESA people were there as well. So all of these folks will also be at Friedrichshafen in June. And, being able to touch base in person, we'll know a whole lot more after June. And then we'll see another large batch of people that we routinely work with at DEF CON in Las Vegas in August. And then looking forward into the fall, to the autumn, I'm not sure where we'll be. There's lots of different places to meet up. But, I think that over the course of 2026, we're really focusing on prototyping our satellite designs, helping other people get things done, supporting anybody that wants to do ambitious open source digital radio work. And just making sure that it's all really well documented and that it's accessible. So, because a lot of this digital signal processing stuff is not explained well. It's already kind of hard and interdisciplinary, so it's challenging and interdisciplinary, which means that explaining it in an accessible way is very hard. And we can see this very clearly in the software-defined radio world, where if you approach it from the hardware side, you have a certain point of view. If you approach it as a computer science person, as a programmer or coder, that doesn't, your idea of hardware is how fast does the clock go, and that's it. Then you have a different point of view. And when you come into radio, each side, so to speak, has some adjusting to do. That when, coming from a hardware restricted, everything is a radio circuit and everything is very tightly defined. And the challenge is that you could reconfigure and make it flexible and adaptable, and you can offload these hardware functions into software, that you can have something that is very adaptable. Coming from the software side, it can be an adjustment to realize that physics is getting in your way, and you can't just write your way out of it or skip over anything. Like the physics of radio will end your your idea. It will constrain you in ways that you might not be used to. And so you can see, that's a pedagogical challenge, and if you're trying to teach or do anything with software-defined radio, then you have to be sensitive. Some people are going to come at it from a totally different perspective than you. And if everybody's going to work together to advance this field, then explaining it in accessible ways becomes very, very important. And this is true of any interdisciplinary field. So SDR is absolutely one of those. So another place that we see this sort of overlap, this Venn diagram, is with FPGA design. So a digital hardware designer and somebody that is also good with communications theory or systems level, digital signal processing. Having somebody with both of those skills is pretty rare, so you need to have people that they're coming from one side or the other, that the concepts that they need to learn need to be accessible and not just repeated in the same old way. You can't just throw math at a bunch of people and expect them to just get it. So examples, worked out examples. Open source is really powerful here because you can actually say, look at this design. This implements exactly what we're talking about. Walk through from the top to the bottom, pay attention to the comments, and then sit with it, and then you'll get it. And that often can be more valuable than years of book learning to somebody that's trying to come at it to get things done. So that's where we're kind of at Open Research Institute. That's kind of what we do, is bring this stuff alive and make sure that it's accessible and inspiring, and that it's solving a real problem, something innovative that needs to be liberated, maybe from proprietary or commercial work, or something that has been overlooked because commercial enterprises have a particular set of needs. They need to make a profit for the most part. And since we don't have to have that pressure on us. We're able to explore things and bring them out into reality that may have been overlooked. So that's part of what drives us here. All right. So yeah, any last comments or questions before we close for the day? All right, everybody, thank you so much for coming. So if you want to learn more, openresearch.institute/getting-started is a great place to go. So if you're listening to this and you'd like to join, welcome. We have a Slack for daily engineering, an email list for announcements and discussion. We have a newsletter subscription, so just keep up with our work via a newsletter. YouTube for meetings like this and for presentations and walkthroughs. And we just have a lot of encouragement for you to tackle these things in engineering and science. And until next week. So thank you, everybody. See you soon.